Okay, today we're going to continue our lessons on comparing numbers in scientific notation, and we're going to use the rules of exponents that we had learned in previous lessons, making sure we understand that when we're dividing, we're subtracting exponents, and then when we multiply, we're adding exponents. We're going to start with this problem, and again, I apologize for having to go so quickly, but YouTube limits me to only 15 minutes, so we have to get this done within a 15-minute time frame. You can always stop the video and rewind it if you need to go over different parts. All right, so Earth is about 1.5 times 10 to the 8th kilometers from the sun, while the planet Neptune is almost 4.5 times 10 to the 9th kilometers from the sun. The distance from Neptune to the sun is about how many times the distance from Earth to the sun. So what we're going to do is model this in a couple different ways so that we can see ways to figure this out and make it simpler for us. So 1.5 times 10 to the 8th is approximately 150 million kilometers, while 4.5 times 10 to the 9th is actually 4,500,000,000 kilometers. To find out how many times greater 4,500,000 is than 150 million, 4,500,000,000 is more than 150 million, we're going to divide 4,500,000,000 divided by 150 million. That's a lot of work and a lot of effort. But we can use scientific notation to figure it out a lot simpler. So let's take a look at how we can do that. The first thing we do, we're going to break it into as two parts. We're going to compare 1.5 times 10 to the 8th and 4.5 times 10 to the 9th. The first thing we're going to do is compare the decimal part, which is 1.5 and 4.5. 4.5 is about how many times as great as 1.5? Well, we know that 3 times 15 is 45, so 1.5 times 3 should be 3 times as much, right? So that should be 3 times right there, 3 times as much. Then we're going to compare 10 to the 8th and 10 to the 9th. Well, 10 to the 8th is, 10 to the 9th is 10 times as large as 10 to the 8th. So this is 10 times. All right. So how many times greater is 10 to the 9th? And that's 10 times. All right. I want you to remember that. So if we do those together, 3 times 10 is 30. So we should be looking at about 30 times as great. That's how simple it can become in scientific notation, because this actually ends up being 3.0 times 10 to the first, which is 10. Okay? Now, let's take a look at the next problem on here. How we look at that? We did this already. How many times is 4,500,000,000? Then how many times bigger is it than 150 million? Well, we looked on the first page and we said it's about 30 times as much. 30 times. All right? And then how much was 4.5? How many times was it 1.5? We said it was 3 times, because if you divide 4.5 by 1.5, you get 3, right? And it's also just like saying 15 times 3 is 45, and just put the decimal points in. So 1.5 times 3 is equal to 4.5. That's my reasoning for that. And 10 to the 9th is 10 times the value of 10 to the 8th, right? Because it's a power of 10. So 10 to the 8th times 10 to the first gives us 10 to the 9th. Everybody remembers that when you multiply, you add the exponents, right? So it's 10 times as much. Now, let's look at 13 and 14 together. If I get 3 times and 10 times, I multiply those together, I get, the answer is 3.0 times 10 to the first, which is the same as saying 3 times 10, which is going to give me 30. Okay? The question number 16 says, which method would you use to compare the numbers? That's going to be really up to you, but I would look at it like this. I would use it in scientific notation, because that was much easier than trying to divide 4,500,000,000 by 150 million. That would take most of us all day to do. So I would have, and the reason is because you don't have to keep track of any zeros. The zeros go away, right? You just have to count the exponents. All right, so let's go down here to the next problem, and let's see how can we use what we learned to figure out this next problem. We want to know how much larger is the 6 times 10 to the negative 5 is how many times the value of 3 times 10 to the negative 8. So we have to set this up as a division problem. We have 6 times 10 to the negative 5. We're going to divide that by 3 times 10 to the negative 8. We're going to do this in two different steps. We're going to first divide the decimals, and we do that, we get 2. 6 divided by 3 is 2. And then we're going to keep the 10, and then we subtract the exponents. You have to be very careful here because when you subtract these exponents, it's negative 5 minus a negative 8, which means we keep this at negative 5, change this to a plus, and change this to its opposite. Negative 5 plus 8 is actually equal to 3. So it becomes 2 times 10 to the third, which will make it 2,000 times. Does everybody follow that? If not, stop the video and think about it. Talk to the partner next to you and see what you can, if you can clear it up. And the last problem that we're going to do is star A is 3.4 times 10 to the 18 miles from Earth. Star B is 6.8 times 10 to the 16 miles from Earth. So star A is how many times as far from Earth as star B. Again, we set this up as a division problem, but notice that we need to find out star A here is how many times as far from Earth as star B. So we need to look at, we have 3.4 times 10 to the 18th, and we're going to divide that by 6.8 times 10 to the 16th. We do the same division. 3.4 divided by 6.8 is actually just 0.5, right? 0.5 times 10 to the second, because 18 minus 16 gives us 2, all right? And if I move that decimal over, I get 50 times. But remember, this is not written in scientific notation because I don't have a number, a decimal between 1 and 0. So the true decimal form for this is to say 5 times 10 to the first, because we move that decimal over that way 1, that means that this has to go back the other way, minus 1, to give us equal to the first power. So our answer is 50 times as much. And that's all you have to do with comparing numbers is remember the rules for exponents when you divide and multiply. And you should have time now to do your homework, which will be on page 35 and 36. And if you have any questions, I'll be back tomorrow and you can we'll discuss this homework and we'll discuss any questions that you have tomorrow. You can rewind the video as much as you need to, and I'll see you tomorrow.